Here's section 7.1, exercise 24. In this exercise, we're given a couple of functions and find the area of the region. So mostly I want to do 24 and then I'll do 26 and kind of contrast. So here's 24, and we're told that f of x is equal to the cube root of x minus 1, and g of x is x minus 1. Well, okay, we could graph these, and sure, I can do that, but then we can go look at Desmos to kind of see how we did. So this first one is the cube root function, which looks like that. There's 0, 0, and the axes. But then it's got a minus 1 inside, so it got moved to the right by 1. And so my f of x, I think, looks something like that. And so there's f. And then x minus 1, well, that's a positive slope with a y-intercept of 1. Now, notice that a y-intercept of 1. Oh, wow, okay. So there's that one. And as I look at this, I kind of think, do they ever meet? Good question. And, I could check some things like, I can check some easy values and just kind of hunt and peck, so to speak, right? If I do f of 2, I get the cube root of 2 minus 1, which is 1. And if I do g of 2, I get 2 minus 1, which is 1. Oh, okay. So, oh, yeah, and I said a y-intercept of 1. I don't know why I said a y-intercept of 1, but, just trash talking, I guess. So y-intercept of negative 1, all right, so there we go, negative 1, and maybe it does something like this. It's tangent up here, something along those lines. But I think we're going to get some region in there. And I can, again, try to draw it a little better, starting with that one. And then, and actually, so that does go through 1, 0. So, it's not tangent. It probably does that. Okay, and there's 2. There's negative 1. Okay, so I play around with it, and I'm pretty confident that's what it looks like. Well, let's go look at Desmos. And in Desmos, I hadn't plotted it yet, so I'm going to kind of cut right to the chase, I guess. So I'm going to do x minus 1. And I probably need to put parentheses around that. So that then I can do that and do 1 divided by 3. So there's to the 1/3. So see, it's that S shape. And then I have the x minus 1. And there we go. So it does look like we want the area in between these two. And so there are two areas that appear to be the same size. Okay. So I think what I would do is I would integrate from, say, 1 to 2 and double that area. Okay, so if we do that, come back here. So I need to set up an integral from 1 to 2, and we did the cube root on top there, so that's x minus 1, and then minus x minus 1 on the bottom, so we're doing this one, dx, and I want 2 of those. That's my area. So then that equals, well, 2 times the integral from 1 to 2 of the cube root of x minus 1, and then minus the integral from 1 to 2 of x minus 1 dx. So I went ahead and split up those two integrals, where notice then a way to interpret this is that this first integral, I'm finding that whole area, and then in the second integral, I'm finding that area, and the area I want is the difference of the two. I'm going to get that area in there by taking the larger area minus the smaller area. So I can think of it that way. So this is equal to, well, I forgot my dx there. This is a u substitution for this first one. If I let u equal x minus 1, then du is just dx. And my limits, u of 1 is 1 minus 1 or 0, and u of 2 is 2 minus 1 or 1. And so that first integral, I go from 0 to 1 of u to the 1/3 du, and then minus this integral that I can just do right now. I get a minus x squared over 2 and a minus x from 1 to 2. And so that's equal to u to the 4/3 over 4/3. My poor u's and 4's look a lot alike. From 0 to 1. And then minus, now be very careful about minus signs and all that. So I put the 2 in first. So I get 4 over 2 minus 2. Oh, well, that's just 0. And then minus 1 over 2 minus 1, like that. And so this is equal to, well, when I put 1 in and invert and multiply, I just get 3/4. And then we'll put 0 in, I get 0. And then now, okay, that is just 0. This was minus a half. But then I have a minus and a minus and a minus. So this is minus 1/2. And so I get 1/4 as my area there. Okay. And so, you know, I get those. We could always check that. It never hurts to check work. So I go back to Desmos. And I'm going to edit this and call that now f of x equals, just so I don't have to retype quite as much, I don't think. And this one, I will, could take me as long to add this one as type in x minus 1, I suppose. So g of x equals, so I have those two functions. And now I want to take 2 times the integral. Oops, not the natural log. Let's try that again. The integral, there we go, from 1 up to 2 of f of x. There's f of x minus g of x. Oops. And dx. And it doesn't like that. Okay, well, so the f of x, g of x, that all looks fine. 1 to 2. So my best guess is I'm going to add parentheses, and there we go. And we get 1/2. Oh, see, technology, isn't that grand? Go back, right? I had 1/4. Well, yeah, what did I forget? I forgot my 2 along the lines there somewhere, right? So I had my 2. Now, see how sloppy I was? There's a 2. And so I need my 2 there and my 2 there. Whew. Tell you, it's tough to get good help nowadays. So there's 2's. And so I have a, oops. So I have a 2 times that and a 2 times that, which just gives me 2 times that, and I get 1/2. Always nice to check your work. Getting sloppy, I guess, in my old age. But again, you know, I can, somebody else might call me lazy. Maybe even I might call me lazy. But I do think it's very important for you to see that I'm a, you know, I'm a reasonably accomplished mathematician in that, hey, I've made it through a PhD. I've solved some nice problems. I've gotten some papers published. I sort of know what I'm doing. You know, I've worked for industry, but I can screw up and leave things out just like you can. It's not the end of the world, but oops, now look at that. And you know, so I can even say stuff, right, and write down something different. So 2 times 1/4 would be 1/2, which is what we got. But I tend to check my work. And that is a huge difference between people who end up being able to publish, so to speak, not in the sense of journals and so forth, but to give to someone else, right? To relay to someone else correct mathematics, and somebody who doesn't is, you know, I screw up all the time. I'm wrong all the time. You do a lot of mathematics, you are wrong a lot. But what you do is you take the time to look at it and ask, did it make sense? And hey, it did make sense. 1/4 sounded good to me. But I took all my tools available. I went to the technology and I checked it. I was wrong. Okay, so I fixed it and I saw where I needed to fix it. I had just gotten sloppy and left those 2's out. Okay, so I had the great idea here, multiplying by 2, but then I screwed it up because I got a little sloppy. Okay, but in the end, the answer is 1/2. And another thing one could check is, well, if we went from 0 to 1, as long as we're here and we're taking this time, if we go from 0 to 1 on this thing, we thought we ought to get the same answer as from 1 to 2. So here we see our answer from 1 to 2 is a half. If I had my keyboard out, I could copy this thing really fast. I don't know how to copy it with like just my finger or something. It just doesn't highlight, so I don't know how. So let's just put it in here, and let's just do an integral from 0 to 1. We should get a fourth for this. So an integral from 0 to 1. But in this integral, g of x is on top. So I have g, oh, well, let's backspace and get that parenthesis in that we know we're going to need. G of x minus f of x, and close that parenthesis and then do our dx. And there's our 1/4. So indeed, we were correct that the symmetry is working for us there, and we could just do one of those and double it. And so if I'd done the 1 to 2 and gotten a fourth, and then the 0 to 1 and gotten a fourth, great, same answer as doing twice either one of those pieces. Okay, so we'll put that one to rest.